All right, folks, on this Monday, we are back for round 2 of dividing square roots. So, we are talking about doing problems that look like this. We could do 10 square roots of 80 divided by 2 square roots of 2. Now, what we learned is that to divide square roots, we divide the outsides. So 10 divided by 2 would be 5. And then we divide the insides. 80 divided by 2 would be 40. And then after we get that answer, then we simplify it. So we would now simplify 5 square roots of 40. So to do that, we need 2 numbers to multiply and give us 40. We need one of those to be a perfect square. So you're going to need your perfect squares list. 40 is 4 times 10. 4 is a perfect square. He's in the list. Simplifying a bit more, we know that the square root of 4 is 2. So this is 5 times 2 times the square root of 10. And we end up with 10 square roots of 10 as our final answer. So this is what we did on Friday to divide square roots. We divided the outsides, we divided the insides, and then we simplified the answer. Now, today we're going to look at division problems where things aren't quite as simple. So here's the first problem we'll do for today. We're going to do 3 square roots of 8 divided by 8 square roots of 5. 3 square roots of 8 divided by 8 square roots of 5. Now, to divide, we're supposed to divide the outsides. 3 divided by 8, I can't do. I can't do at least without getting a decimal, and I don't want decimals. And then we're supposed to divide insides. Notice on the inside, you're supposed to do 8 divided by 5. Now again, I can't do that division, not without getting decimals, and I don't want decimals here. So, today we look at what happens when division is not possible. When we can't do the outside divided by the outside and the inside divided by the inside. Now, you would think that since we can't divide, this problem would just be over. But one of the rules for square roots is that you can't have a square root in a denominator, which remember is the bottom of the fraction. So no square roots in a denominator in a final answer. So this is one of those rules of algebra. You are never allowed to leave a square root in a denominator in a final answer, which means that I can't leave this problem like this. I can't divide, and I can't leave it like it is. So when this happens, you are going to use a process where you rationalize the denominator. So this process that we're about to do, called rationalizing the denominator, is going to allow you to get that square root out of the denominator when division isn't possible. So how do we rationalize the denominator? Well, here's what you do. You multiply the top and the bottom by the square root on the bottom. All right, so here's what we're going to do. Let's look at the square root on the bottom. The square root of the bottom, on the bottom, is the square root of 5. So we are going to multiply top and bottom of this fraction by that square root. So I'm going to come out here and I'm going to do times the square root of 5. And I'm going to come out here and I'm going to do times the square root of 5. So first, let me make sure this is clear. First, we check to see if we can divide. We cannot. So because we can't divide, we are going to rationalize the denominator. So you take whatever the square root is on the bottom, and you multiply it by the top and the bottom. All right, now, I need you to keep in mind that we are multiplying right now. So when we multiply the outsides and the insides. So on the top, when I multiply the outsides, 3 times 1, just going to get 3. And then when I multiply the insides, the 8 times the 5 is going to be 40. Now on the bottom, when I multiply the outsides, 8 times 1 is 8. And when I multiply the insides, 5 times 5 is 25. Now, at this point, we'll need to do some simplifying. So on the top, 3 square roots of 40, we're going to need 2 numbers that will multiply to give us 40. One of them needs to be a perfect square, so we're going to go with 4 times 10. On the bottom, notice your 25 is already a perfect square. Square root of 25 is just 5, so that's going to be 8 times 5 down there. So we're in luck on that one. All right, working on the top, we have 3 times 2 times the square root of 10. On the bottom, 8 times 5 is 40. See, a little more simplifying I can do on the top. I can do 3 times 2 and get 6 square roots of 10 over 40. And I want you to notice what has happened here. We have gotten rid of that square root that was on the bottom. It went away, which is the whole purpose of doing this. So there's a square root on the top now, but not one on the bottom. That's what you want. Now, let me talk to you about this. We have simplified the square roots as much as we can. But because this answer is a fraction, there is one more thing that you're going to need to check here at the end. You're going to need to see if you can reduce to lowest terms. Now, to reduce to lowest terms, what I need you to do is to look at your outside numbers, your 6 and your 40, and we want to see if there is something that will go into both of those. Both of those will divide by 2. So to reduce, we're going to divide the top by 2 and the bottom by 2. So we are going to end up with 3 square roots of 10 over 20. That would be your final answer. Now, I know that seems like a lot of work, and it is, but I want you to notice that you're using skills that you already had. So to kind of recap, first we checked to see if we could divide. I couldn't divide the outsides, I couldn't divide the insides. So when you can't divide, rationalize. To rationalize, you take the square root on the bottom, and you multiply it by the top and the bottom. Outside times outside, inside times inside, gives you this. Then we simplified our square roots. And then at the end, because it's a fraction, check to see if you can reduce to lower terms. So all of the skills that you're using are skills that you already have. It's just a matter of thinking your way through it. Now, if you check your division problem and you can divide, then do it. But if you can't divide, then this will be the backup plan. All right, so let's look at another one. Let's look at the square root of 8 divided by 2 square roots of 14. Now, let's start by looking at this square root on the top. Please understand and know that his outside number, it's not showing, but his outside number is a 1. So let's check and see if we can divide. Can we divide the outsides? No. Can we divide the insides? No. So on this problem, regular old division is not possible. So we're going to rationalize. The square root on the bottom is the square root of 14. You are going to multiply that by the top and by the bottom. So now we'll multiply outsides and insides. So on the top, 1 times 1 is 1. 8 times 14 is 112. So we get the square root of 112. On the bottom, multiply the outsides. 2 times 1 is 2. Multiply the insides. 14 times 14 is 196. All right, time to simplify each square root. So on the top, we're going to need two numbers that multiply to give 112. You want one of those to be in your perfect squares list. So if you start dividing 112 by those numbers, you'll find out that 16 will work. 16 times 7 is 112. On the bottom, 196 is a perfect square. He's in your list. The square root of 196 is 14. All right, continuing on. On the top, we can do the square root of 16 and make that 4 square roots of 7. On the bottom, 2 times 14 is 28. Now, look how nice and neat that is. That's looking much better than it was. Now, here is the last thing we need to check. The answer is a fraction. So we need to see if it will reduce. You've got 4 and 28 on the outside. Is there something that will go into both of those? The answer is yes. Both of those are divisible by 4, so we're going to do that to reduce. 4 square roots of 7 divided by 4 makes 1 square root of 7. 28 divided by 4 is 7. So we end up with the square root of 7 over 7. So I checked first to see if I could divide. If I could have, I would have done it. I couldn't, so I rationalized. Multiply top and bottom by the square root that's on the bottom. We simplify the square roots and then simplify the final answer. All right, let's do one more here, like that. Let's do 6 square roots of 2 divided by 5 square roots of 6. All right, so first, let's check to see if we can divide. Can you divide the outsides? No. Can you divide the insides? No. So we are going to rationalize. We take the square root that's on the bottom, and we multiply that by the top and the bottom. So we checked it first to see if we could divide, and we couldn't. So now we're rationalizing. We're multiplying top and bottom by that bottom square root. All right, on the top, when we do outside times outside, inside times inside, we should end up with 6 square roots of 12. On the bottom, when we do outside times outside, inside times inside, we should get 5 square roots of 36. All right, next up, we're going to see if we can simplify these square roots. First, we need two numbers that will multiply to give us 12. One of them has to be a perfect square. Has to be in the list, so it looks like that'll be 4 times 3. 36 is a perfect square, so we can go ahead and make that a 6. Square root of 36 is 6. So up top now, look what we have. We have 6 times 2 times square root of 3. On the bottom, 5 times 6 is 30. 6 times 2 on the top gives us 12 square roots of 3 over 30. Now, when you get to this point and it feels like you're done, check one more thing. Outside numbers, 12 and 30. Can they reduce? Is there something that will go into both of those? Both of those are divisible by 6. So 12 divided by 6 makes that 2 square roots of 3. 30 divided by 6 gives me 5. So 2 square roots of 3 over 5. All right, so that gives you 3 of those to go on. Now, let's look at just a couple of other problems here. All right, on this one, we're doing 6 divided by the square root of 3. Now, let me talk to you here just a second. A lot of you are going to be tempted to do that 6 divided by that 3, because you know you can do that. But the problem is that 6 is an outside number, and that 3 is an inside number. You're allowed to divide outsides, you're allowed to divide insides, you're not allowed to divide one of each. So this is a division problem that we cannot do because one number is an outside number and one number is an inside number. You should always start, though, by checking to see if you can divide. In this case, we can't because we have an outside being divided by an inside, and we can't do that. All right, so if I can't divide, what am I going to do? Well, I'm going to rationalize. So I take the square root that's on the bottom, and I multiply it by the top and the bottom. Now, when you multiply outsides, you multiply insides. So that means on the top, I can't multiply the 6 and the 3 for the same reason. One's outside, one's inside. So that is going to be 6 square roots of 3. On the bottom, though, I can multiply because both of these are inside. So that's going to be the square root of 9. So I end up with 6 square roots of 3 over the square root of 9. Now at this point, I should try to simplify my square roots. So I need 2 numbers that will multiply to give me 3. The only numbers that will do that are 1 and 3. So that's not going to simplify. That's going to stay 6 square roots of 3. Square root of 9, though, I can do because 9 is a perfect square. Square root of 9 is 3. Now, one last thing. Before you leave the problem, always look, as your last step, always look at these 2 outside numbers to see if you can reduce them. 6 and 3 will both divide by 3. So I should do that to reduce this. That's going to make it 2 square roots of 3 over 1. So that means I would just write this as 2 square roots of 3. That would be the simplest way to write it. So always check first to see if you can divide. If you can, you should do it. If division is not possible, then we go straight into that rationalizing process. And then simplify as much as we can. All right, now, this next problem, compared with the others, is going to look a little weird. Now, the thing that makes this problem different from the others that we've done is that it's not 2 square roots. We have here the square root of a third. Notice, though, that is still a division problem because 1/3 means 1 divided by 3. I can't do that division. I can't do 1 divided by 3. So I'm still in the same boat here. It's like the others in that I can't do the division. I can't do 1 divided by 3. So here's what you're going to do first on this one. You are going to split this up into 2 square roots so that it looks like the problems that we've been doing. So when they give you the square root of a fraction, split it up into 2 square roots so it looks like the others we've been doing. Now, as we've already discussed, we can't do this division. We can't divide these insides. So when we can't divide, we rationalize. So you're going to multiply top and bottom by that bottom square root. All right, when we multiply the square root of 1 times the square root of 3, we get the square root of 3. On the bottom, when we do the square root of 3 times the square root of 3, we get the square root of 9. Now, these square roots need to be simplified if we can. So on the top, square root of 3, we'll think about two numbers that will multiply to give us 3. One needs to be a perfect square. The only way to get 3 is 1 times 3. That won't help. So the square root of 3 is as simple as it's going to get. Square root of 9 I can do, though, because 9 is a perfect square. Square root of 9 is just 3. Now, remember what I've told you here. When you get to this point, when the square roots have been simplified, you always need to check the fraction to see if it will reduce. And we check the fraction to see if it will reduce by looking at the outside numbers. On the top, we don't see an outside number. On the bottom, we see a 3. When we don't see an outside number up here, we know there's an invisible 1 there. 1 and 3, the only thing they'll both divide by is 1, so this won't reduce. So your answer on this should be the square root of 3 over 3. That's as far as that's going to go. I know I'm doing a lot of examples here, but I want to make sure that I cover all my bases. So we're going to do one more. I'm going to do the square root of 3/20. The first thing I'm going to do is rewrite this as two separate square roots, so it'll look more like these other division problems that I'm doing. Now, let's check to see if we can divide. Can we do 3 divided by 20? And the answer is no. So it's not possible to divide. So we rationalize. So you're going to multiply top and bottom by that bottom square root. All right, multiplying the outsides and the insides on the top, I'm going to get the square root of 60. On the bottom, I'm going to get the square root of 400. 3 times 20 and 20 times 20. All right, now I'm going to look at these square roots to see if they'll simplify. So for 60, I need two numbers that will multiply to give me 60. One of them has to be in my perfect squares list. I think I can do 4 times 15 and get 60. On this bottom square root, I don't need to split it up because it is a perfect square. The square root of 400 is 20. So, simplifying the top a little more is going to give me 2 square roots of 15 over 20. So now, square roots have been simplified. Let's check one more thing. Outside numbers. Will they reduce? 2 and 20. Well, I know both of those are divisible by 2. So this is going to be the square root of 15 over 10 for my final answer. All right, so when we're dividing square roots, there are two types of problems we're going to run into. There are problems where we can do the division and problems where we can't. So always check that first. Can you divide the outsides? Can you divide the insides? If the answer is yes, then do it. And then simplify your answer. If the answer is no, I can't divide the outsides, I can't divide the insides, then we go through this process that we're learning today. We rationalize the denominator, which requires that we multiply the top and the bottom by whatever that square root is on the bottom. And then we do all of our simplifying. Now, I realize that this is a lot of work. There are a lot of steps. So you may have questions. I am available. I will be on my computer all day checking my email. So if you're having trouble with this, if you have questions, then email me and let me know, and we will take care of those.